Hello, my name is Fabian. Today I'm going to be talking to you about React and TypeScript. I did want to thank the Houston React Meetup group for allowing me to present this tonight. We are recording tonight's session, so in the case that in case you miss anything, you want to follow up on some of the material that I cover, do know that I will be getting you that video. I'll either post it in the as a comment for this Meetup event or in the discussions, but I'll find a way to get you the presentation, including the slides, videos, and any repos, or there's one repo that gets used. So with that, I guess let's begin. I want to start off by mentioning that I am not a TypeScript expert. So I guess let me clarify on that. I'm still learning, but I've been using TypeScript for probably, I guess, a better half of about like 8 months now. And from what I've learned, I love. I will never go back. I will never revert back to vanilla JavaScript. And so I'm hoping today's presentation will convince you of that as well. At least kind of get you a good jump start with TypeScript. And so at the end, by the way, we are going to be adding TypeScript to an already existing React app, which I know as a React developer is one of my biggest concerns is like, well, okay, how is this new language or this new framework going to affect my already existing code base? So with that, let's go ahead and let's start. So again, my name is Fabian Buentello. Plot twist, I'm actually an iOS developer at Chai1 here in Houston. So I'm not even a JavaScript developer like professionally, but I will say that I love it regardless. And what's really cool about Chai1 is that so our clients are in the enterprise space, so oil and gas, energy, manufacturing, which allows me as a developer to really have some interesting problems come through my desk. And as I mentioned before, my loves are JavaScript and Swift. So, in a text editor on my computer, it's one or both of those languages at the same time. So if you were here in my previous presentation, a brief history of front-end frameworks, you'll know that I like to theme my presentations, this one being no different. Today's theme is going to be Anakin Skywalker from episode 3 specifically. Yes, I see you back there. And a photo of Jack Black. We'll see who's paying attention because I'm going to sneak his photo in somewhere during the presentation, so it's up to you to catch it when it happens. And okay, so now the agenda. What are we going to be going over today? I want to talk about the 3 certainties in life, followed up with JavaScript's love-hate relationship, introduce TypeScript, then show you, a quick TypeScript demo to showcase, what it brings to the table, and then wrap up with adding TypeScript to an already existing React app. So the 3 certainties in life. I felt it was fair to open up the presentation with this, which I'm assuming you as developers or JavaScript developers know what these 3 certainties are. That is death, taxes, and you will either love or hate JavaScript. Nothing in between. I've never met anyone that's like, yeah, JavaScript's okay. Like, never. It's either you love it or you hate it. And finally, there will always be off by 1 error, so prepare yourself. So, JavaScript's love-hate relationship. What is this? Why? I guess we'll start off with why I love JavaScript. Right now, I'm pulling up my notes on this part, make sure, because I have a few things to mention. Here we go. So why do I love JavaScript? First of all, it's the freedom. I mean, as of right now, I can be a front-end developer, I can be a back-end developer, IoT, and just recently I can do native mobile apps with React Native. So the cool thing about JavaScript that it's always evolving. And again, if you haven't seen my previous presentation, I do have it uploaded, and I can. It is as part of reference for this presentation, so you'll get a link to it. I do give some insight as far as how JavaScript has evolved since its early days, and so I want you to know the JavaScript that you knew 5 years ago is not the JavaScript that you know today, and the JavaScript you know today will not be the JavaScript of tomorrow or 5 years from now. So that's why I love JavaScript. It's always changing. And so for the most part, like 9 times out of 10, my thoughts towards JavaScript is, I love you. You're so beautiful. Where you've been my entire life. Like if you were a person, I would marry you. Drop on one knee, right? But then at the same time, I'll have these moments where it infuriates me. Like, why do you do this to me, JavaScript? Like, what is this variable? Where is it coming from? So why? Why do people hate JavaScript? To me, as an iOS developer and having many different types of developers within our shop, the opinion of JavaScript is very polarizing. I've actually never witnessed that. I've never seen that with another language. I don't know if you have. So why? I feel to get into why, we have to go over two things, and that is static versus dynamic programming languages and strong versus weak. So the first one, static versus dynamic. And to simplify it, all it is, the way that I read it, is when does the compiler check for errors? Is it before compile time or during compile time, or is it after, during runtime? So let's pretend, in fact, I'll show you an example of this. And all of a sudden you assign it to an int, it's just, a red flag gets thrown saying, hey, I can't compile this, I can't run it. Some examples of statically typed languages are C#, Java, and Swift. And so typically with statically typed languages, you'll see they'll have, IDEs, and you'll have errors kind of get brought up to your face saying, hey, by the way, you can't do this. So for example, in Swift, it's not .linked, it's actually .count. So the benefit of statically typed languages is you kind of catch these errors early on. Now, on the flip side of that coin, you have dynamically typed languages. These are languages that do the type checking during runtime. So what exactly does that mean? And we'll show an example a little bit later on, but you know this with JavaScript. As far as examples, be JavaScript, Ruby, and PHP. So meaning you can program or you can write your application, hit run, and it shows the web app, and it's not until that line of code that has the error gets executed when you are actually made aware that, hey, I got a bug in my code. So here's a diagram to kind of show you to illustrate what I'm talking about. So as a programming language goes from left to right, it goes from being dynamic to static. So on the left-hand side, we see Ruby, Python, JavaScript, and on the right-hand side, C#, Haskell, Java. It's where you'll see Swift over there on the top right. But then on the other axis, on the y-axis, you see weak going to strong. So what does that mean? This actually brought up a really good debate within our dev team, and that's what we're going to be going over next. So weak versus strong. Let's just go straight into an example. So Ruby, it is a dynamic language, just as JavaScript, but is strongly typed. With Ruby, I call this main function here, and I do print the number 4 plus the string 4. What does Ruby do? It throws an error at me and it says, hey, I cannot convert this number 4 and the string 4 to give you an answer for whatever you see or whatever it is that you want. So this is a strongly typed language. You do have type conflicts as far as if you try to do things that just don't connect right. Now, a weakly typed language like JavaScript, which is also dynamic, we're going to pay attention closely to the console log. So in the first example, I have a number, an operator, and a string. And when I do 4 plus 4, the number 4 plus the string 4, what JavaScript does, what the interpreter does, is it converts the number 4 to a string, and then concatenates it to the second 4, and then spits out the string 44, right? So like, oh, okay, cool. So that means if I switch out the operator for a multiplication, or the asterisk here, if I do, since they gave me a string the first time, I'm probably expecting 4, 4, 4, 4 4s, right? But no, instead what it does, it now converts the string 4 to a number and then multiplies it across, giving me 16. So what's the problem? To me, what I feel why people hate JavaScript is because they cannot trust the language. If this is part of the language, how much trust do you have in it that you don't, as you're filling in a text field, or as a user's filling in a text field, that you're not converting a string to a number or vice versa correctly? At least for me, I don't know. My code, if my JavaScript code, I don't know if I have much confidence in that. So I know what you're thinking. Liar. How can you do this to me, JavaScript? Like, you have, as you're writing your application one way, not really expecting, you can't think of every single type conversion. That's just 2 examples. There are so many on the web. You can even find it on What the JavaScript, the video. I forget who the presenter is, but he shows a lot of these types of examples where it's just like, oh, okay, it's one way, but then he shows you, he just like flips the operator or flips one type, and all of a sudden it's a completely different answer. So, other things that I hate about JavaScript: ambiguous code and hacky JavaScript code. So what does that mean exactly? So I'm gonna paint a picture for you here. Let's pretend we just got dropped into a JavaScript project at work, and you didn't write any of the code, and you need to, by the way, I'm actually painting to you a real life scenario that I went through. You didn't write API service.js here. I don't know if you can see it all that well, but you're completing the feature you're completing the settings screen, right? And you're like, oh, okay, well, let me go to the API service.js file and let me see what endpoints I have available. So it's like, well, okay, here's get settings. And why don't you know, this is one of the rare times you don't have documentation, right? So I mean, because you always have documentation. So I'm like, okay, get settings, it's expecting a payload. Well, okay, I mean, I don't have any documentation. Let me go into the function and let me find out what is payload, right? So I go into it, and all of a sudden payload gets passed into parseX header, and I have no idea what is payload. So what do? Like, okay, well, you know what? Let's go into parseX header, and chances are parseX header has documentation, because whichever person wrote this, jerk. I go into parseX header, and why don't you know? There's no documentation. So now I'm like, oh, okay, now I'm into another function to figure out what this variable payload is. So I go into parseX header, and off its first line, I now figure out that payload is actually, I can infer that is an object. It has a property X navigation and property X navigation and property site code. But just know, at this point, you didn't know if payload was a string, a number, an array. You had no idea until you got all the way down, 2 functions in, to figure out, like, okay, it's an object. But now, what are the values supposed to be for those properties? So then I go down, one more level. I'm like, oh, oops. Okay, X navigation seems to be a string. I can infer that, but I don't know for sure. So at the end of it all, I'm like, oh, okay, payload, it's an object, has 2 properties, X navigation and site code, that are both strings. So now, as for the second example, hacky code. So I will take full ownership I'll take full ownership for the code that you're about to see. I wrote this. To give you some backstory, I have a cousin who does property tax consultant or advisor, and he's constantly crunching in numbers. And as a developer, just like, hey, just fill in these fields, hit go, and boom, it's done, right? So him and I, he pretty much wanted a souped-up calculator at the end of the day, right? So we have this connected to a backend that has these properties that's for the county, for Harris County, right? And the first year was perfect, right? We have this function here called format for display. What we do is we pass in an invoice, and we grab its property. And we grab its properties, and we do some addition, and append or prepend a $sign symbol to it, right? So okay, cool, everything's perfect. Well, just as every single application and project evolve, new feature sets come out, right? And all of a sudden, the following year, it's like, okay, Fabian, we now need to be able to take care of properties outside of Harris County. And I'm just like, crap, like, I don't even know where I'm going to get these, like, the data set's not even available. And so I was like, you know what we're going to do is you're going to be inputting custom properties. So you'll be filling in the numbers and everything, but it'll still go in your system. And I was like, well, okay, that's the only way that can work. So what I want you to do is focus on this rate variable, right? This is what it ended up turning to. Because so what I ended up doing was checking to see if the invoice had a custom property flag, and if so, we're going to grab the rate out of the custom property. If not, then we're going to grab the rate from its previous from the original rate path. Well, the thing was, I had to do it for every single property inside of this invoice. So what I ended up doing is it turned a 30-line function to a function that was nearly 100. Now, yes, I could have gone to the call site of this function and made some adjustments, but then if I were to do that, I could have introduced bugs or more bugs. Bugs always exist, right? So I was like, well, okay, this is the cleanest way I can add this feature without breaking so many things. Now, like I said, I take responsibility for what it was, but the problem. So what's the problem, right? Well, you can be like Jack Black over here and just put like Vaseline over your eyes and pretend like what I'm saying doesn't make sense. But what my opinion is that because JavaScript allows this type of behavior, code like this slips in between the cracks. Yeah, it's a nasty image. So there are some things that I really wish that JavaScript had that could have prevented stuff like this from happening. The ambiguity, the ambiguous code, and the code that turns into the hacky JavaScript code that you saw earlier. So what is that? To me, I found that answer in TypeScript, and so that's what I'm going to be showing you now. So I guess before we do, let's go over what is TypeScript. So TypeScript is a statically typed superset of JavaScript that compiles to plain old JavaScript. It starts with just regular JavaScript with an optional static type system, but when compiled, it all goes away. What does that mean? Well, a superset of JavaScript is essentially just a layer above it that is making you as a developer code a certain way, but at the end of the day, it is just what comes out the other side is just plain old JavaScript. And so it's not, though yes, it is technically its own language, but yes, it is technically its own language, but what I end up learning, months into it that I kind of wish that someone would have just, slapped me or at the beginning and told me, hey, by the way, this is what you need to be paying attention to, was that with TypeScript, I felt that, oh man, I'm going to learn TypeScript. There's all these new things I got to learn, like whatever it is. I mean, I don't want to pick up Backbone, but if I were to pick up Backbone, Backbone.js, I'm going to have to learn all these new concepts, all this, my workflow is going to change. How is that going to affect my code as it is? That's not the case with TypeScript. What TypeScript does essentially is you get your variable or your function, and you just are adding types to it, saying, hey, this variable is a string. This function is expecting a number and a string. So to kind of give you an example, here's JavaScript. Let's pretend inside of your React application right now, this is what you have. You have a full name, Bob Bobbington, which is a string. You have age, which is a number. List, which is an array of numbers. Person, which is an object with two properties, name and age. And at the very bottom, you have a function add that takes in two properties and returns the addition of those two properties, right? Well, okay, let's pretend that is inside of your React app today. If you want to add TypeScript, all you're going to be doing essentially is saying, hey, full name is a string. Age is a number. List is an array of numbers. Person is an object, which I know this one looks a little bit funny. I'm going to be talking to you about interfaces in a bit, but person is an object with two properties, name and age, and here are those types. And oh, look at the bottom example here, function. It's the function add. It takes in two properties, which are both numbers, and returns you a number. That's all TypeScript is at its most basic level. You get your code, your regular JavaScript code, however it is written today, and all you're doing is going to be adding types. By doing so, you're going to find your code is much more, I guess you would say, much more, I don't want to say implicit, the opposite of implicit, explicit, there you go. That was a test, y'all passed. Since your code is going to be written in such a way that you'll be able to know, oh, okay, this is what this function is expecting. There's no way that I can, cram in an array of strings whenever it's expecting, a number. But in fact, we'll scratch that. Let's go and let's get into an example actually. So right now I'm going to be showing you the TypeScript playground. And let me go ahead and open up Chrome. Y'all can see my window. Okay, so there will be a slight lag, which is cool. Slows me down as a developer. So let me zoom out a bit. Can y'all see that okay? All right. So on the left-hand side, you have TypeScript. On the right-hand side is what TypeScript produces out the other side once you compile it down or transpile it. So for example, you still have inheritance. Everything that you have with ES6 that you love, you still have, which actually, by the way, scratch that. Let me take you back to the TypeScript website. Kind of skip the step. This is TypeScript's website. Here's where you'll find all the documentation, all the getting started guides with React, Angular, Vue, and anything that you'll need to get up and running tonight. I will mention this video, See TypeScript in Action, at the very bottom was actually a really good video, and I'd recommend anyone who's getting into TypeScript to check it out. But with that, what we're going to do, we're going to go to the top right here, Playground, and here you'll be able to write TypeScript and test out and see what it comes out the other side. So as you kind of see, or in fact, as you can kind of infer, this is what Babel does under the hood. The only difference is that you're actually declaring types for your variables and your parameters. So this looks really, really messy. What we're actually going to be doing is, let's zoom in to the left-hand side here. And, okay, that's probably a little bit too much. There we go. So I'm actually going to be grabbing the example that I had from earlier, the API service. So, okay, cool. This is your JavaScript code right now inside your React app, all right? Check out what I'm going to do. The first thing I want to show you is let's start messing with parameters, because to me that is like the #1 bug that ends up happening with JavaScript. Is you either don't pass in the parameters in the correct order, or you pass in too many or too little. So we're gonna let's just copy this out right now. And as I hover over parse X header here, it tells me that TypeScript's able to infer that, okay, we have a parameter called payload of type any, which I'm gonna explain what that is, and it returns an empty object, right? I'm gonna go over here and parse X header, and same thing. TypeScript's able to infer all this. So what we're gonna just do, we're just gonna change this to a 4, okay? I'm going to come back over here. So if, let's say, for example, you're coding and you're like, okay, I got to use parseX header in this other file. I'm just going to do is hover over it, and then all of a sudden, boom, TypeScript tells you, hey, it expects a payload of type any, and it's going to return to you a number without you ever having to say number, or declaring that this function returns a number. So I'm going to go ahead and revert that back for right now. So the next example, let's actually make payload a string for right now, okay? And okay, so same thing. As you hover over parseX header here, you'll see that, okay, it expects a payload of type string. But what we're going to end up doing is we're going to change this payload up here inside of get settings to a number. TypeScript doesn't like it. It's saying, hey, you're trying to pass in, the argument number is not assignable to the parameter of strings. You're like, oh, okay, well, I didn't know that. Let me go ahead and instead of a string, you're going to be, or in fact, we can do is, there you go. Hey, now it works, right? But I'm not recommending this, by the way, okay? But I'm just saying that, like, okay, TypeScript's able to help you catch these type of bugs that don't lie to yourself and say you don't write, because I know for a fact you do. So let's revert back and let's actually finish up the example that we had initially, right? So, okay, remember before, like, we now know that payload is going to be X. It's an object with 2 properties, X navigation and site code, right? So I mentioned earlier something about an interface. Now, you saw earlier with whenever you saw that example that TypeScript already had classes, you saw the junk that it generated. Well, interfaces are a little bit different. They're not classes. In Swift, we call them protocols, but they're essentially contracts that say, or in fact, just as classes inherit from other classes, you conform to an interface, or you conform to a protocol in Swift world. So whenever I say an object conforms to this interface, what I am saying that this interface, and we're going to go and write one right now, interface I, and by the way, the common practice for recommended practice for interfaces is to prepend whatever it is that you're creating with capital I. So we're going to say header payload. Okay, so a header payload will have a X navigation, which is of type string, okay? Oh. And it's going to have a site code of type string. Cool. So now what I'm going to say is payload down here is of type, conforms to the header payload interface. So that just means that payload here, and as I scroll over, in fact, let's pretend you didn't have any of this code down here. Oh, crap. So, what's up? Comma on line 9. Where am I at? Oh, no. Good catch. Or not necessarily good catch. I'm not saying that you're wrong or anything, but so the thing about interfaces, these aren't necessarily objects themselves. These are just declarations saying, hey, this is, an X navigation, a string. That's one thing that kind of messed with me at first with interfaces. I'm so used to putting commas, but you actually don't need to in this case. I don't know. Let's see. Does it complain? Technically, no. So I can't say that that you would be mistaken if you did, but
interface is not part of JavaScript.
That is
TypeScript that goes away.
Correct. Pure TypeScript. So let's pretend like you didn't write any of this code, right? And you're like, okay, well, payload has payload conforms to the header protocol or header payload interface. I'm sorry, not protocol. Says like, you know what? Let's just say payload dot, and look at that. It automatically auto completes for you. Now later on, I'm going to be showing you this example in Visual Studios. But whenever you have multiple classes across different amount of files, though, yes, if you install the correct packages into your text editor, it does autocomplete for you. Nice, but I would tell you this is not going to be as nice as TypeScript from my experience. It's autocomplete. It's just on point every single time for me. But let's go back real quick. So okay, so now with our current example here, we know that payload is of the header payload interface. So that means we know for a fact that you will have to, in order to use this function, you have to pass in an X navigation and a site code. If you don't believe me, let's pass in an X, or look at it, even auto-completes for me here. So we're going to say it's hello. Now, of course, I need commas and say site code world, right? Like, okay, cool. Well, let's pretend I didn't have a site code. TypeScript throws an error at you, say, no, hold on, you told me that if you want to use parse header, you need to provide an object with X navigation and site code. So I can tell you right now, with your JavaScript currently today, you do have those actions that don't have payloads. Typically an action has a type and a payload, but you do have those ones that are just types. Well, this TypeScript alone will help you catch so many of those bugs that that get by you. So let's just revert back to payload the way we had it here. And so, like I said, by this point on line 14, we know that if you're inside of this function, you are providing an object that conforms to the header payload interface. So this if statement actually becomes quite useless when you start thinking about it, because I don't need to check, hey, is payload true? And if so, do either of these two objects exist? No. So let's actually get rid of it. And okay, that makes a little bit more sense. And now, like I mentioned, we now know that if you want to use this function, you need to provide a string for both these properties. So now this default value here that we had doesn't really make a lot of sense anymore, right? So my code actually looks a lot much easier to follow. It's much more simpler, if that's a word. And for the giggles of it, let's go ahead and say that payload here is actually header payload as well. I'm like, okay, cool. So we just converted that example to TypeScript. Well, you know what? Let's zoom out and let's see what TypeScript generated. Because you remember what happened last time with all the classes, how it created all this noise that was hard to follow in the case that you're debugging in production. Well, look at that. This is what TypeScript generated. This is what I love about interfaces and protocols. In Swift, I don't know, correct me if I'm wrong, but the practice is called like protocol-oriented programming. I believe that's right. And that's the way that we like to do a lot of our development, where instead of inheriting from a class and having these giant, monolithic classes that have all these that are inherit, 20 parent super classes, we like to do is work with protocols. And to me, this is beautiful, especially the fact that TypeScript does not generate any code for an interface. Like I said, protocol and interfaces, same thing. Okay, so to further illustrate this, let's actually change the header protocol that we made here. Let's change it into a class. Oh, now we generated some code. Now things get a little bit noisy to follow in the case that you actually need to debug some production. But like I said, to me, my rule of thumb is always to use interfaces. But of course, depending on the situation, it may of course be better to use classes. But so with that, we're going to go ahead and go back to the presentation if I can find it.
Real quick, can an interface provide a default for properties?
No, actually, don't quote me on that. I'm pretty sure it does not yet. Prevents you. And TypeScript is always evolving, so I mean, who knows? Maybe there may be a point where default properties. I know with Swift we can do such a thing, but as of right now, no. So let's go ahead and let's go back to our presentation here, and oh, that's what we're going to be doing. And okay, yeah, now let's actually add TypeScript to a React app, which I'm sure is the reason why you all came here, because you're probably like, Fabian, I don't believe you, it's going to be as easy. Let me get rid of this. Okay, where is my Visual Studio Code? Okay, cool. Sorry, I know you see a lot of things moving. All right, I'm done. No more. Okay, cool. So first, let me just run this program or this application just so that kind of like you know what's going on. And
Visual Studio Code is the only thing you should be using for TypeScript. So that's supported.
Great question, Lester. Visual Studio Code. So the question was, do you have to use Visual Studio Code, or is Visual Studio Code? Yeah, is Visual Studio Code the way I want to go when I'm doing TypeScript? From my experience with with other text editors like Sublime, Atom, plugins don't always work 100%. Things are like, you might get that like 90, 98, 98.5, maybe not quite 99%, like, that awesome experience. But when it came to, and so that's with anything, at least from my experience it was, right? But whenever it comes to TypeScript and Visual Studio Code, like, the experience is awesome. And don't get me wrong, I love Sublime. I have all my key mappings, like me and Sublime, like if I could marry a text editor, it would be Sublime. But unfortunately, I'm not gonna say unfortunately, because it's actually an awesome experience. But Visual Studio Code has the best experience whenever it comes to TypeScript. So if you aren't using Visual Studio Code currently, or if you are, good for you. You're gonna have a jump start on everything because all your key mappings are gonna be already set. But you can still use TypeScript with Sublime. They do have packages, but I can't speak to them as far as what the experience is like. And you're gonna see you're gonna have an IDE type experience with this. So with that, let me go ahead and do a quick brief as far as the package, or excuse me, this overall package that you see before showing you in fact, I'm going to show you the application. What I decided to make, I didn't want to do a to-do list app because it's like really basic, and I mean, we kind of overdid. So like, you know what? Let me go ahead and just add like an additional feature to a to-do list app. So instead of it just being a string of text, I'm going to allow you to add an image or a video, right? So I was like, you know what? Instead of it being a to-do list app, boom, let's make a feed, quote unquote, right? So all this red stuff, these errors, we want this because this is where we're going to be applying our TypeScript to the error portion of our application. But before doing that, let me just run through this application real quick. It's really simple. So let's say it was a feed. So we're going to say, React, Meetup, TypeScript, in fact, and then our body, TypeScript is awesome. And, we'll hit create. Oh, crap. This is why you always reset. I needed a way to generate those bugs or those errors. So I had to like put in some faulty code, error-prone code. So, okay, let Webpack recompile. Scratch that, pretend you didn't see that. Let's go back. Okay, so React Meetup TypeScript is awesome. Oh, I might have to just refresh real quick. React Meetup. Cool, awesome, man. Imagine if it didn't work. Oh, I've been sweating. Okay, so like, you can like things, you can delete, you can filter. Apparently we don't have any images. Here we have a video. And like I mentioned, I do want these errors because this is where, the way I have my React application set up is if I encounter any errors, I want React to spit that out to the actual screen so I can see it. And I don't have to always have the console open to see if anything happened, right? So, okay, that's a quick overview as far as the application. It's pretty simple, nothing too crazy. Now, I wanted to go over as far as the application itself. How is it working? Because as a React developer, you're probably thinking like, hey, you know what, Fabian? You're probably not using all the tools that I'm using, and this is just it's tailored to to be TypeScript like. Well, the first thing that I did want to mention is we are using Babel currently, ES6 React Stage 1. We are using Webpack to build out our application. So if you're using Grunt, I can't speak to Grunt, or Gulp. And here's our Webpack config file here. Let me get rid of this console here. So I mean, everything looks pretty basic. So we have an entry point, we have output, we have source map, dev sort, dev server. Our extensions here, and then our rules. Kind of looks pretty basic here, right? And lastly that I wanted to mention is, as far as the structure of the directory, I didn't want us to have a actions folder, a reducers folder, a components folder, because it would have been, I didn't want us to be jumping all over the place during this demo. So what I decided to do is just kind of like to have a component, all its I guess all of its files live within a directory. So with errors, we have the error actions, the component, the container, and so on for all the other parts. So it's not necessarily a recommended practice. I know there's different ways, but the only reason why I'm doing it is so that way we can just have one directory open. It's easy to follow. Okay, things are about to get messy here. Be prepared. Okay, so let me hide this sidebar here. I guess the first thing that we want to do is is to add TypeScript to our project, right? So let me go ahead and pull out the README here. I have it somewhere. Here we go. So let's put that over here. And this should be, okay. So adding TypeScript to this project. There's three things that we're doing. I know you're seeing, we're going to be doing is updating dependencies. That is this entire section here. We're going to be adding this file called a tsconfig.json. This is one of the things that I'm still learning, all the different parts of TypeScript. What this tells TypeScript to do is how to transpile your application. Okay, what is the target? If you want ES5, ES6, which libraries are you using? And to kind of show you, let's go back to Chrome real quick. Let's go back to TypeScript. Let's click on documentation here. And over here on the bottom left, you'll see project configurations. And by the way, the documentation for TypeScript is actually pretty awesome. It is very readable. Some examples do get real in depth, but as far as the tsconfig, it does go over what that is. But what I wanted to show you was the compiler options. So you can do one or two things. You can either pass in these options as flags on the command line, or you can have them as or inside of the tsconfig.json file, right? So I actually wanted to add one more to it, right? So it's like no parameters. There you go, no unused parameters, right? The experience why I'm advocating for VS Code is because I can copy this and paste it over, right? Well, VS Code, given that it's created by the same team, I'm going to go to, actually, we're not yet. We haven't actually created the file yet. I'm sorry, scratch that. Let me get rid of this real quick, and let me go back over to our README here. So we're going to do three things: update packages, create our tsconfig, and we're missing a flag here that I want to add, which is no unused parameters, which we'll do later. And we're going to be updating our Webpack. That's it. Three things: packages, tsconfig, and Webpack. Yes, Lester. That's correct. So, well,
So does that mean when React comes out with a new version, you can't use it for a while until the TypeScript guys update all the types?
so really good question, and I cannot speak for the React team. Of course, I wish I could. That'd be cool. But in fact, let me go ahead and let's install TypeScript now. So we're adding the awesome TypeScript loader and TypeScript as dev dependencies. And we're going to be doing that next section. We're going to be doing what you're talking about next. I really need to organize. Okay, here it is. Cool. So what Lester is talking about here are the types for the dependencies that I'm currently using. So the thing to note that some of the dependencies that you already have, some of the packages, they have TypeScript included, and I actually will say that a lot of packages have these types already included in their package, but some of them don't. So
for each new release, they come out with the updated types from the developer. Is that what you're saying?
Correct. So the TypeScript team, let's pretend we were all the TypeScript team, right? It is not our responsibility to go and update these packages. The React team, whenever they release a new, maybe at the beginning, but as far as the adoption of TypeScript is actually quite large. Like the amount of packages, I believe it's definitely in the thousands. I don't know. I want to say the number that I heard was like over 1,400. 1,400 packages. I could be mistaken, but I know that it's not like if you come across a package, you won't. I would say that you're probably not going to be running into the fact that it doesn't have a type declaration, which we'll get into what that is. But what Lester's talking about is, so with these packages, like, okay, they have vanilla JavaScript in it, right? But we kind of need TypeScript. So that way TypeScript can read its types and know what these functions are returning or what they're expecting, right? So that's what we're installing here. So let's go ahead and, man, Sublime is, let's move Sublime all the way over here so it's out of my way. Okay. So we're going to install these types. So we're installing the types for React, React Bootstrap, React DOM, React Redux, and Redux as dev dependencies. And actually, I need to follow up. Yeah, these technically should still be dev dependencies if I'm not mistaken. And so the last thing that I wanted to do is something that not a lot of examples really show you and I want to prove it to you that we are no longer going to be using Babel. So I'm going to copy. We are going to be removing all the previous Babel stuff that's currently in your project now, right? Because I'm assuming one of the fears that you're going to be having is like, okay, I'm adding TypeScript, but what is that going to mean? What does that mean with Babel? Because everything's like Babel right now. So let's copy this and
doing live coding and throwing away the net.
So, okay, we're removing all our Babel modules, and just to be sure, I don't need that many windows open. Like, Lester, check your front pocket right now. I'm just kidding. No, I'm kidding. So just to even give you more assurance, what we're going to be doing is we're going to delete our babel.rc file here because I want you to be confident that what I'm showing you is complete TypeScript. So we already done two things. No, we haven't. We've done one thing. We need to add our tsconfig file, right? So let's just go ahead and let's add a new file here. Inside our root directory, tsconfig.json. And let's go ahead and let's copy over our example here. Now, to do some reading, as far as like the, I guess, package bundling portion, which is like the outsource, source map, the modules, libraries, that part is kind of just for TypeScript to know, like, okay, where do you want me to put all this stuff that I'm going to be writing, right? The one where TypeScript really shines, the part of TypeScript that you really want to know is like, okay, allow JavaScript. Do you want TypeScript to allow JavaScript, or do you want to just like no JavaScript, complete TypeScript, right? They have another flag called strict, which if we go over here and let's look up strict, you'll see like it enables all these other flags. So for example, no implicit any, no implicit this, right? And here are the values. So here's what it expects, and here is its default values. So, right? So let's go ahead and let's add that that flag that we want. It's like I said, I can copy it, from the website. But again, why VS Code is so awesome at this is I can just type in parameters and there it is, auto completes it for me. So like I said, given that it's the team, I don't want to say that they are the exact same team, but the fact that the teams are so close together, the TS experience, TypeScript experience that you have with VS Code is just I can't expect this type of experience with any other text editor. The last thing that I actually want to do is I want to get rid of. This was while I was rehearsing. While I was rehearsing this presentation, we're gonna be adding a file called a declaration file later. And while I was rehearsing, it wasn't working. I was freaking out. I was like, "Why is this?" And so ended up is because of this line right here. I was not looking. It was only including TypeScript, TSX, and TypeScript files. So right now, I just want to include everything. So this is more so like to make sure that the demo goes accordingly. So okay. Let's go back to our example or our to-dos here. So we've installed our packages, we've installed our tsconfig. Now let's update Webpack. You know what? I'm a huge desktop person, and when things aren't where I expect them to be, I have horrible, get anxiety. So let's go to our Webpack here, and can that be? So the first thing that we need to do is let's go ahead and let's add, because we of course still want to include JS files and JSX. So let's add .ts and .tsx. Okay, cool. The next thing, actually, I want to make sure I don't miss anything. Okay. The next thing are the rules. So previously, the rule that we were looking for was, okay, test to see if you have any JSX files. And by the way, I'm going to admit that when it comes to like the rules and I'm no Webpack guru, okay? I'll be the first to admit that I go online and I like find the examples that is closest to my project. But as far as our rule, it's pretty simple. It's testing for JSX files, and the loaders that we're using is that React hot loader that we all love that, refreshes your screen as soon as you save, and then our Babel loader here, right? Well, all we're going to be doing, and I don't want to copy it all, but all we are doing is going to be updating it from .jsx to tsx and JSX. And instead of using React hot loader and Babel loader, we're just going to be using awesome TypeScript loader. That's it. It is awesome. So let's copy that and let's just paste it over this already existing rule. And that's it. Okay. So the moment of truth here, things can go either like an all you, or things can go like really wrong, right? Where is my keyboard? There we go. Give it a second.
Webpack output is served from root.
Oh, look at this. It's already complaining. Wow, how did things go wrong? Let's go to our changes here. Did I forget to do? Now, truthfully, this isn't actually part of the demo, so things actually did go wrong. That's what I get for opening my mouth too soon, right? Readme TS, let's get rid of JSX. Oh, did I get rid? I'm just restarting, getting rid of all of our anything that I know should not have been edited. So we've updated our package, and by the way, this is what it looks like. We removed all our Babel, we added our types, and we updated our TypeScript loader and our React hot loader, right? And our Webpack config, we just added TS and TSX, and we updated our rules here. So let's see. Apparently I didn't clean my directory prior to coming up here, so that's my bad. Fingers crossed. Okay, thank God. Okay, cool. All right, so we have a green light here, but do you believe me? All right, let's go to Chrome and let's go back to our application. Let's refresh, make sure nothing's cached. Okay, cool. And let's just say, OMG, it worked. And we'll actually add a video link just so that way. Okay, That's done. And let's just add a video link to the body here. Okay, cool. Things still work. We still have our errors down here that we wanted. I can still like, I can still delete. Okay, nothing's changed. So to take a quick step back, what we've done is we got in our ES6 application and we're now transpiling with TypeScript, not Babel, right? So, okay. So just to prove to you that, like, okay, you can use regular JavaScript with TypeScript, but now you're probably, your next example, or excuse me, your next thought is probably like, oh, well, okay, Fabian, well, what I'm thinking is, can I use, does it have to be TypeScript that imports JavaScript, or could JavaScript import TypeScript? So let's just do that. Let's do that example now. So in fact, actually, before I do that, I have to tell you the way the structure. So our entry point to the application, if we follow Webpack, it is going to be source index.jsx, which is right here, right? Source, index.jsx imports app.jsx, and here's that file here. Here's that file now. So what we're going to be doing, and right now Webpack is running. What we're going to do is we're going to rename app.jsx to TSX, and Webpack's going to fail because it currently has app.jsx, in memory, or whatever that process is, and it's like, hey, what happened to app.jsx, right? So unfortunately, we do have to quit it out, but that's fine. That's cool. So, all right, let me get rid of all these tabs to make sure. So the first thing you probably see, get rid of our sidebar here. Our file here is getting lit up, right? That you're like, well, Fabian, I thought you said we imported the React stuff. What is this error that tells me, cannot find export for React? Well, with React and React DOM, you actually have to import everything as React and import everything as React DOM. It's just a rule of thumb. So, okay, next thing is the props here is declared, but its value is never read. So that's telling me that props actually isn't even being used. And the second error that I'm seeing is that let's hover over that. So parameter props implicitly has an any type, which is one of the flags that we set with that strict, saying I don't want that. So since we're not even using it, let's get rid of it, right? So okay, let's save that and let's bring back the console, clear it out, and yarn dev. I want to see how long we can go in silence. So, okay, it's loading up now. And let's go back to our application here. And there we go. Everything still seems to be working. We can still filter. Everything looks good. And in fact, we'll just add an image just so that way our filter works as expected whenever we hover over images. TS image. It's an image link. And okay, cool. Now we have an image whenever we filter. But okay, cool. So now we have JavaScript that imported TypeScript. So I have addressed that concern that you may already have. So the next thing that I want to do is like, well, okay, well, you know what? Now let's really start nailing down. And by the way, we're not going to be adding TypeScript to every single one. So I don't want to make you feel that we're going to go through all that. But there are some key ones that I want to go over. So index.jsx. Let's rename that to index.tsx. Okay.
When you say importing TypeScript, by the time it's importing it, the TypeScript is just JavaScript.
Well, when it's importing it while developing it, yes, at the end of the day. So the question is, when it runs, all of it is JavaScript. Correct. So you aren't necessarily it's not like Java importing a C++ file or nothing like that. But that's always a concern that people have, is like, well, could I import TypeScript? So of course, as last time, import everything as React DOM. Okay, let's see what else lights up in this file that TypeScript can catch. So for example, it says error. It implicitly has an any type. So for right now, let's actually make it an any. Okay. Oh, that's not what I want. There you go. And the next one that we see here is React. So window, TypeScript is able to infer that window, the global variable window, is of type window, and the error that we're receiving is the property React does not exist on type window, right? So this is that JavaScript stuff that you all do unknowingly that you're like, well, you know what, let me just attach this .react property to a window. Well, TypeScript's telling you, hey, by the way, you're not supposed to be doing that. So the way that we get around this is we actually add this comment, tsignore, just kind of like how you have with ESLint. You can ignore lines, so it ignores the line beneath it. The purpose of this demo is to tell you that when you have the type any and tsignores are not your friend. If you jump into a TypeScript project and you see this throughout the project, get out, because these are not your friends. So you should not be using these lightly. At any time, whenever you have, if something has to be any, you better have a good reason why it needs to be any. At least that's my rule of thumb going forward. So go ahead.
Why don't you just modify the type for window and make it what it really is? Is that not the TypeScript way for window?
Well, window, I can't answer to that. I don't know. This demo, I couldn't find.
I mean,
So
somehow you've imported a window definition, the types for the window object.
Correct. Yes.
But you can't. Once you've imported them, you can't change them. You can't modify them for your project.
I can't say yes or no. I don't know. I've actually haven't gone. All the types that I've declared, I have made. I haven't gone and actually made modifications to an already existing. Like, for example, in Swift, you can extend. You can write an extension for a type. So maybe I haven't seen extension with TypeScript. I know I've Googled it, but
you have to make a new type window extension or
something like that.
Code would be harder to read.
Yeah. Or you can have a tsignore and write your comment as far as that. But like I said, as far as this demo, I just wanted to show you what tsignore and what any is, and that you should not be using that. The next thing, so okay, we've done the app, we've done index.
That does put a hole in your code where
yes,
you can make type errors now.
Technically, for that next line, yes.
Yeah.
So like I said, tsignore is definitely not your friend. But if you have to use it, you should not be using do so not so lightly, I think it's the phrase. So the next thing is, okay, let's actually add, oh, this filter. Why is filter in here? Filter should not be in here. Filter should be out here. Oh, yeah, live coding at its best. So apparently that's, I guess that was the error. I accidentally moved filter up, and that's the reason what it didn't like. Let's compile real quick to make sure I didn't just ruin the project. But what we're going to be doing is adding, oh, so I just ran it, and what do we have this error from Webpack? Oh wait, so if we remember, inside of our webpack.config.js, our entry point is index.jsx. It should be index.txx. So let's just rerun that again. And come on. All right, cool, we're good. So the last thing that we're going to be doing is we're going to actually convert an entire component just to give you proof that both can coexist together. So we're going to be doing the error. And again, that's the reason why we have all these errors down here. I know I'm switching between these screens very quick for you. So I just want to make sure, let's convert our errors to TypeScript, because given that they're probably the easiest, they're not as complicated as some of these other components, be a good example. So what I like to do is to start off with the most vanilla JavaScript files that you have. Files that don't import libraries, files that are just, you just have very basic JavaScript. There's no imports. I mean, in this case, it's just a constants file, but very little can go wrong here. Given this demo, something could still go wrong. So what we're going to be doing is, let's rename action.js to TS, and let's make sure, okay, it's not running yet. And let's change message here to string. And actually, what we're going to do is, in the meantime, let's do yarn dev. Because I want to show you that awesome TypeScript loader actually does live reloading for you as well. So though I removed Babel hot loader, awesome TS loader, awesome TypeScript loader has that feature for you built in already. So we're going to do is going to let this run, right? And what I want to do is okay, so by the way, TypeScript's now throwing an error saying, hey, you have this ID that has an implicit type any, right? Well, let's make ID here a string, and let's save it. And there you go, it's recompiling. So let's go ahead and, this is probably, like I said, the reason why I like working with actions is because it's very vanilla, right? So what we're going to do is let's create an interface to there we go, error action, and it's going to be a type, it's going to have two properties, string, or excuse me, it's going to have two properties, type and payload, there you go, and both of which will be strings, okay? And so now what I'm going to say, or what I'm going to declare, is that add action will return an an error action, and so will clear error. There we go. And so now in the case where I accidentally don't pass in, or I'm not returning where I'm not returning a payload, TypeScript's going to yell at me saying, hey, I thought you said I'm supposed to be returning a payload. So this is something that I love. It catches these small mistakes. So the next thing we want to do is probably the reducer here, and let's go back to our function here. So if you remember, one of the actions that we had was clear error, right? So we're going to go ahead and delete one of these, and unfortunately, since it's okay, it did delete it. The first one's called input.hello is not a function. Okay, it is gone. I probably should maybe delete some of this, that way it doesn't have to scroll so far. Okay, cool. So now let's go into our reducers here, right? So I'm going to go ahead and quit it out, or stop Webpack, and let's rename reducer to reducer.ts here. And okay, like I said, our file here is lighting up, and we're going to return, message is going to be a string, and ID will be a string as well. And we actually have one more error, and it's saying that ID is not being used. Now this is a real catch that happened whenever I was writing this up, that whenever I decided that I'm actually going to generate a UUID, I completely forgot to remove the ID parameter. And so TypeScript was actually able to catch that for me, saying, hey, you're not using this parameter. Are you sure you want it still? So let's go ahead and let's actually remove this. And lastly is, this returns a new error. So I'm actually going to create a new interface called error item. And it's going to have an ID of type string and a message of type string as well, right? And so now let's copy error item here, and let's say it returns an error item. Okay, so now let's go down the list here. We have action here, which is of implicit type any, which we don't want, right? Well, we kind of already made that error action, so let's actually copy that over. And if this is smelling, fishy to you, good, because it's supposed to. So let's copy that code over, and let's say that action is of type type error action. And so next is like, oh, well, TypeScript's there to help you, saying, hey, by the way, you were only expecting one argument, but you sent in two. So let's go ahead and let's remove that. All right, cool. The next one that we have is ID. So ID does not exist on type never. If we kind of look at state here, state is an array of never, which is a void. It's no value. So what we can say is state is an array of error items. And there you go. So you can write an array two different ways, like this or like that. I don't like it like that, and that's my preference. And we're going to say this returns an error item array as well. Okay, cool. We just converted this entire file to TypeScript. Now you have confidence in this file that you won't be accidentally passing in an object as a message, right? Because we all have seen those messages that we try to print out, or when we're expecting a string, but we end up getting an object, and we just see object dot, I think it's object, something like that. So okay, cool. We've secured this file. Awesome. What we can do is do yarn dev real quick to let it run, and let's move on to our next file here, to our container.js, right? Oh. And go ahead and let that load. I just want to refresh the page and make sure nothing broke. It's that initial load that takes forever. go and let's refresh that. And okay, everything looks good so far. We're going to clear out the value here. And now we're at input.hello is not a function. Okay, cool. Yeah, everything still works. Awesome. So let's go and let's just convert our container and our component now. So let's rename our container. And we're going to do is our state here. So now applying React or Redux, like how we do things. Okay, well, you know what? State's going to be an array of error items. So what we're going to do is let's grab our error items here from reducers. And state will be, let's create another interface here that's going to be state store, and it's going to have an errors, and it's going to be an array of error items. Okay, and so now we'll say our state is of type state store. And so now you kind of think about it, whenever you declare your store, you now can start defining, hey, this is what each one of our properties or each one of our little smaller stores or our keys are. This is what our store looks like. This is what it expects. So this is something that I like, that feels pretty awesome. So like later on in this example, I'll have feed in here, filters. So okay, cool. Let's go ahead and let's go down the line here. We have dispatch. Now this is where you start wanting to become more familiar with what types are included with the packages that you bring in. So dispatch is part of the React Redux package. And so now, okay, cool. So for example, let's say you were to pass in a number here. Of course, JavaScript's going to complain at you and say, no, you can't do that. So, okay, we're done with our container. The last thing, and if I remember correctly, what was brought up was our prop types earlier, right? So I myself, whenever I learned React, I didn't, I guess, quote unquote, learn the correct way. So I never did prop types, right? But then whenever I started doing TypeScript, or I've heard of prop types and I've seen them, and I always forget to do them because to me it's always been extra work. But now with TypeScript, to me, I wouldn't consider a new form of prop types, but just as we did, we're going to create an interface that will essentially be our prop types here. So let's create actually, before we do that, let's rename our file here to component.tsx. And what we're going to be doing is interface.error component props, and say that props, if we hover over props here, we'll see that we have an onClear error function, and we have an errors property here too, right? So we're going to say is onClear ID string, and we're going to have errors and it too. Let's bring back our reducer here that we had. Oh, that's not that one. And if you're seeing a lot of copying and pasting, just know that, yeah, that's going to be the next demo here. So our errors here is going to be an array of error items. And by the way, it's lighting up saying that we are implicitly returning a type any, which we don't want. So let's actually say that onClear error is a void. It doesn't return anything. And we'll say that our component here is of type error component props. So as you kind of see, this error component props acts as a form of prop types. Prop types, correct? That's the term? Okay. And so we're going to say ID here is a string, and I think that's pretty, oh wait, and we can't forget our import everything as React. And so now let's go ahead and yarn dev. Now the experience that I have with prop types versus doing it in this way with TypeScript is with prop types, I'm not made aware that I am misusing this component until runtime. Is that correct? Yeah. So with TypeScript, it's the opposite. I will be made aware if I try to use a component and I do not provide the correct properties to that component. So to me, that's been a huge plus. So if I try to, and we can go into the container and show and demonstrate that, but let's go and let's just refresh real quick on our feed just to make sure that we are getting the absolute latest. Everything here still seems to be working. So as the last demo that I wanted to show is, you saw that we were doing a lot of copying and pasting of these interfaces, right? And I'm pretty sure as a developer, you don't want to be doing that. Maybe the first thing that you want to do is have them in a file and then export them out. Well, TypeScript has this thing called a declaration file, which we're going to go to TypeScript's documentation real quick. And it gives you an introduction, and this is, you know, those or the @types React Redux things that we imported. This is what we're importing, these files. So I'm going to show you how to create one here for your application. So these are essentially the types in your application, right? At a global level, they have the do's and don'ts, some templates that you can follow because certain projects might expect them to be different. So in our case, let's go ahead and let's create one. You can have this file anywhere in your directory, just so long as it's in the included. What I mean by that, remember this little change that we made here with include? This is where this is why I'm doing this, because I accidentally had the file that we're about to create, the declaration file, out in the root directory, and it was freaking out. And I was like, let me just change this here. So what we're going to be doing is adding it to a directory that I'm calling typings. It doesn't have to be in this directory. It can be anywhere you want. But typings is the old practice, and so to me it's just a little bit easier to follow because I might be adding more declarations later on. So what we do is we say declare global, and we export. Now I've made a small framework using TypeScript, but I haven't gone real deep into the declarations. So as far as the example that I'm showing you, I really haven't gone past that. Excuse me. So what we're going to do is, let's open up our index.tss here, or index.d.ts, I'm sorry, and let's start turning some of these interfaces that we had, let's start declaring them at a global state. That way we don't have to continuously copy and paste. So we have the error item here that we need to add. We already have error item and error action, so let's go ahead and let's get rid of that. And let's go into our component here. Oh no, it's our container. That's right. And we have state store. And we can get rid of this error item. So now our interfaces that we made, all our types, are now declared at a global level for our application. So whenever we go and we rerun this, so right now, remember I just deleted it, right? And so Webpack is freaking out because I don't know where these types are. Well, let's recompile it or transpile it with our with our declaration file here, and with luck, nothing should blow up in our face here now. Let's clear this out for now.
So is it picking up that file by declaration, just knowing, hey, I'm going to look at typings folder and look for index.d, or were you defining specifically what that export was?
So I think I heard two questions in there. Was the first question is, did I need to have it as index.d.ts? Is that what I heard?
Basically, how is TypeScript picking this up and knowing to run it?
So good question here. That is actually a really good question. And so what I'm going to do, let's just refresh it just to make sure that nothing's broken here. And now we're gonna hack at this. Okay, we can still we can delete. Okay, cool. Nothing's broke. Well, let's clear out our errors. Now we don't have any errors. So what I actually want to do, that was a really good question. And what I want to do is let's quit this out and let's go back to our I guess let's go to our container.ts here, and I actually want to declare that here inside a container, and I want to see what happens. I don't know yet. Fingers crossed. It seemed to have worked. Now, would I recommend that? Probably not, but I guess with this example, we can see that TypeScript, it does not have to be in an index.d.ts. And more specifically, it doesn't have to be inside the typings directory. That's just something that I do just for, for common practice. But with that, that is actually concludes the demo. Let me quit this out. Let me go back to presentation. Because let's go, okay, let's go back to, so you're asking, because I did declare it as global, correct? So if you go back to Chrome, this is where it has like the do's and don'ts, and it has templates. So depending on how we are following the global.d.ts, but I know if you're having the, I think it's like what's like the AMD import thing that I'm not actually familiar with. I think it's the way like Angular is. In fact, don't quote me on that. But like I'm gonna open up a few of these examples here so you can see. Here's the common practice. So you can export as like, as a namespace, depending on what it is. If you're building an application, some of these may work. If you're building a framework, some of them would work versus maybe not. But this is definitely where TypeScript documentation will come in, and not so much whatever I say for sure. But with that, let me, so presentation, if I can find it, the next slide, if I'm not mistaken, is just questions, which we are at. Did anyone have any questions?